Hello students, the continuation of thermal properties of matter. In this, we are going to learn today molar specific heat, heat capacity and calorimeter and the effect of heat. One by one elaborately we will see students. Yes students, molar specific heat. See the amount of heat which is required to raise the temperature of 1 mole of the substance through 1 degree, which is equal to del Q by N del T. So the CGS unit, calorie per mole per Celsius. The SI unit is joule per mole per Kelvin. And so we can say that if an amount of heat del Q which is required to raise the temperature of N moles of a substance through del T, then molar specific heat, which we said C, which is equal to del Q by N del T, right? So del Q which is equal to, we can say, so del Q which is equal to C into N del T. Okay. Right. Now heat capacity or the thermal capacity. We can say that the heat capacity is defined as the amount of heat which is required to raise its temperature through 1 degree. Then heat capacity we can say which is equal to mass into specific heat. Or we can write S which is equal to MC. Right. This CGS unit which is equal to calorie per Celsius and the SI unit joule per Kelvin. Yes students. Calorimetry. So the branch of physics deals with the measurement of heat. The principle says that whenever two bodies of different temperatures are placed in contact with one another, they share the heat till their temperature becomes equal. So that we are telling heat gained by the cold body must be equal to the heat which is lost by the body. Right. So, the heat which is gained equal to heat lost. Right. So, this is the principle of the calorimeter. See, the calorimeter is a device which is used for measuring the quantities of heat. See the diagram students, that is a calorimeter. Actually it consists of a cylindrical vessel of copper which is provided with a stirrer. See the vessel is kept inside the wooden jacket. The space between the calorimeter and the jacket is packed with the heat insulated material like glass or maybe like wool. It is an insulated material, right? So that only the calorimeter gets thermally isolated from the surroundings. The loss of the heat due to the radiation is further reduced by polishing the outer surface of the calorimeter and the inner surface of the jacket. You are seeing on the screen, right? And the lid which is provided with holes for inserting the thermometer and stirrer into the calorimeter. When the bodies of different temperature are mixed together in the calorimeter, then the heat is exchanged between the bodies as well with the calorimeter. If there is no loss of heat to the surroundings, then according to the principle of calorimeter, as we said, the heat which is gained by the cold bodies which is equal to heat which is lost by the bodies. Right. Effect of heat on the change of state. See, take some ice cube in a beaker. Note the temperature of ice. It will be 0 degrees Celsius. See the diagram that we can take it for the effect of heat on the ice. See, it start heating slowly on a constant heat source. Now, note the temperature after every minute. Continuously, you can stir the mixture of water and ice. You can, if suppose you plot the graph, you will, if suppose you take the record it, the temperature with the time. You can take the temperature in y-axis, time at x-axis. You will obtain the curve which you are seeing on the screen. Like the liquid, then the vaporization, and it will be evaporates, vapors. Right. Here, the heat supplied is being used in changing the state from solid, right? Ice is a solid form to the liquid. That means water. So that we can say that the first stage, the change of state from solid to the liquid is called melting. And from liquid to solid, which we can call it as a fusion. So it is seen that the temperature remains constant until the entire amount of the solid substance melt. So now both the solid and the liquid states of the substance coexist in the thermal equilibrium during the change of the state from a solid to liquid. After the whole ice maybe melts into water, and so we continue heating the beaker. We have to note the temperature which increases till reaches 100 degrees Celsius. When it again becomes steadily, the heat which is supplies and now being used to change the state of water from liquid to vapor. So this state we can call it as the liquid, the change of state from the liquid to vapor, which is called vaporization. Right. Now, you must know here melting point and the boiling point. So, the melting point, which we can say that the temperature at which the solid and the liquid state of the substance coexist in the thermal equilibrium with each other. That we can call it as a melting point. That means it is the characteristics of the substance, but also it depends on the pressure. So normal melting point, which means we can say it has some standard atmospheric pressure, the substance. Boiling point, the temperature at which the liquid and the vapor states of a substance coexist in thermal equilibrium with each other. That we can call it as a boiling point. As here the normal boiling point is the substance at standard atmospheric pressure. Right. Effect of pressure on freezing point of ice. So actually ice which melts when pressure is increased, and again it will freezes when pressure is retrieved or removed. See students, the diagram which you are seeing, a wire which cuts the way through an ice slab without cutting into two pieces. This experiment will given the phenomenon which is called a relay. That means again it freezes. Take a slab of ice and support it on two wooden blocks. Take a metallic wire and attach two heavy weights of maybe like 5 kilograms of each. And put the wire over the slab as you are seeing on the screen, the diagram. And it is seen that the wire which is gradually cuts it, the way through the ice without cutting into two pieces. Just below the wire, the ice melts at a low temperature due to the increase in pressure. When the wire has passed, water above the wire which freezes again. Thus the wire passes through the slab and the slab does not get split. So the way the phenomenon which helps the ice which melts when pressure is increased and again it freezes when pressure is removed. The practical applications, we may see that is by pressing the snow in our hand, we can transform it into a snowball. That means when snow is pressed, its crystal actually melts. As the pressure is released, the water freezes and forming a snowball. And another example, that is skating, is possible due to the formation of the water that layer below the skates. Water is formed due to the increases of the pressure and it acts as a lubricant here. Right? Latent heat. The statement says that the amount of heat which is required to change the state of unit mass of a substance at a constant temperature and pressure. So that the Q which is equal to ml. Here the latent heat L which is equal to Q by M. The SI unit of latent heat joule per kilogram and the CGS unit of the latent heat is the calorie per gram. Okay. Yes students. Hope you understood all the concepts. Thank you students.